In World War II, 6 units or packages of chaff were required to cover the frequencies from 10 megacycles to 11,000 megacycles. These 6 units had a gross weight of approximately 6 pounds and occupied a volume about the size of 4 cigarette cartons. Since this World War II beginning, competition among the major powers to develop more effective mechanical jamming countermeasures has resulted in major refinements in the devices, packaging, and in the techniques employed in mechanical jamming. Perhaps the most significant improvement has been in the development of compact, lighter weight materials covering a wide range of radar frequencies. Today, a single package of chaff weighing 6/10 of a pound and about 1/2 the size of a carton of cigarettes has the equivalent frequency coverage of 6 packages of World War II chaff with twice as much reflectivity. The coverage of wide frequency ranges has been accomplished by combining different lengths of chaff into a single package. Although the width and thickness will have little effect upon the frequencies at which chaff re-radiates or reflects the greatest radar return, the length is highly critical. Rope designed to operate primarily against low-frequency radars is made of metallic strips 3/16 of an inch wide and may be several hundred feet long. A new level spool dipole reflector covering the 320 to 600 megacycle range has been developed. It is a roll of foil cut to dipole lengths. These strips remain in roll form until released from the package. Any type of metallic substance may be used as chaff, but the most common type available in modern electronic warfare is aluminum foil. Special purpose chaff may be directed against specific radar systems. With a remarkable reduction in weight and improved packaging have come new methods of dispensing chaff to make it more effective against radar systems. This cross-section model is of a rocket for forward launching of chaff in a series of pre-timed bursts. The chaff used here is effective against ground and airborne radars. A decoy is a small unmanned vehicle which will present a radar return similar to an aircraft. It can also carry chaff and electronic jammers.
Mechanical jamming devices are designed to accomplish one or more of these 4 basic objectives: to hide or screen targets that are there, to make radar see targets that are not there, to cause errors in the tracking of fire control radars, and last, to degrade the automatic data processing and computer tracking capability of the SAGE system. The mechanical jamming devices and tactics selected by the enemy will depend on his specific objectives in a given attack. A great variety of tactics are available. For example,
a corridor drop is achieved by dropping chaff continuously from 2 or more aircraft flying relatively close together. The chaff trails from these aircraft tend to merge and form the chaff corridor seen on this scope. This corridor drop can effectively screen all targets flying within the area of the corridor. Chaff dropped in random bursts may fill the air with targets that are not there, thus delaying the identification of real targets and increasing the risk of committing weapons against false targets. Off-target or diversionary mechanical jamming may direct attention away from the main striking force by creating a large number of false targets in another area that appear on the scopes as a larger raid than the main attacking force. Delayed opening chaff may be dropped as a diversionary tactic to create the appearance of aircraft approaching at a later time and at a lower altitude than the dispensing aircraft. Forward-launched chaff rockets are designed primarily to protect the aircraft by breaking lock on tracking radars. Chaff dispensed at the proper intervals in any type of drop may completely disrupt the automatic tracking of fighter weapons control radar by causing the automatic tracking equipment to break lock. The radar returns from a large-scale mechanical jamming attack, especially when combined with electronic jamming, may degrade the surveillance, tracking, and weapons control capabilities at the SAGE Direction Center if the chaff data is allowed to be processed as target data. Now let's look at an attack in which the enemy employs chaff. For simplicity, we will follow the sequence of events as it would affect only one SAGE sector. We will assume that a corridor chaff drop is dispensed against 3 radars with overlapping coverage in the sector. The chaff is picked up by the long-range radar. It is seen by the AJ operator, or the maintenance technician, or the mapper and the data quality monitor, DQM. It enters the FST2 data processor and may be accepted as target data and displayed on the RAPI, the Random Access PPI scope. From the long-range radars, the data travels over telephone lines to the parent SAGE Direction Center. Here the data enters the FSQ7 computer. In the Direction Center, as at the LRR, the increase in data becomes the immediate and simultaneous concern of a number of persons. The Air Surveillance Officer, who has the major responsibility for maintaining good surveillance data. Radar Inputs and Countermeasures Officer, who has the responsibility of assisting the Air Surveillance Officer in maintaining good target data by ensuring that proper countermeasures are taken. Tracking Officer, who with his tracking team is responsible for tracking targets. And the Intercept Director, who has the responsibility for controlling intercepts. In this chaff environment, some of the target data does not appear on the situation display because it has previously dropped out due to overloading of the system. This overload began at the LRR. Because so many of these returns from the chaff were processed and accepted as targets by the FST2, there are too many targets for the telephone lines to transmit, and there is dropping of both real and false targets. If other LRRs are transmitting large quantities of data, the DC computer may become overloaded. If this happens, all incoming data will not be displayed. Thus, the data displayed at the DC is a combination of real and false targets, but not necessarily all targets.